Can you see my screen?
Yes.
Okay.
Yes.
Okay. Yeah. Okay. In this demo, I'm gonna show you what we have done to improve the wildcard topic subscription performance in version 4.3, and we also backport it into 4.2. Yeah. So the outline is, first I will introduce the background, or what is the issue, then we will do some root cause analysis, then have some solutions, the solution letters actually. That's how we attack the issue step by step, and then I can show you some results and summary about, because we have added some performance tuning switch or configurations. So there are some summary about what to use in which scenario. And in the end, if we have time, we can do some demo in AWS to see how fast it is. Yeah, I think, yeah, okay. So I already mentioned that we have performance boost in version 4.3 and 4.2. 4.3 has major improvements, and 4.2 has minor improvements. And we introduced a new config called broker performance route lock type, and we have 3 value to choice: key lock, table lock, and global lock. I will explain what are they in the later slide. So background. So we have some enterprise users and open source users. Open source users report they have some performance degradation in EMQX 4 point something. And I listed 2 issues here. Both claims about a number of clients cannot subscribe with EMQX, which runs in a cluster mode. So the factors we found that is, first, EMQX runs in cluster mode. It's not single node. Second, those MQTT clients, they are doing subscriptions on massive different wildcard topics. They are not subscribed on the same or a few. It's a lot. And the pattern we found that is they have those some client ID or some UUID in the topic, so that each client is trying to subscribe to different topics, and that tends to be tons of subscriptions on the wildcard topic. Yeah. So root cause, there are 2. First is the trial tree, as Stone mentioned in his presentation. I can go through it quickly. So in EMQX, the wildcard topics is managed in a trial tree internally, and the tree nodes and edges are stored in Manisia table for publishing matching. Yeah, here I give you a example that if we got a publish message with ABCD topic, and it's trying to find the subscriber which having those wildcard topics. Okay, the second root cause is the Manisia in the cluster. So the manipulating of wildcard topics, they run in Manisia transaction context. If you don't know what is Manisia transaction, it's basically we can say it in other terms. It's a lock and sync. This is very efficient on a single node setup concurrently, but it's not that efficient in a cluster, because the time complexity grows with a number of flat facts. The first is the number of EMQX nodes, because the logs need to be taken on all the nodes. So if you have very slow node and the transaction time will be impacted also. Yeah, okay. Then the second effect is that there are and the number of levels in the topic, which terms to be a number of nodes of a child tree or child node in the child table, or the nodes and the edges in child tree you need to update. So for example, for this topic, there are like 8 nodes, 1 + 1 root node, and that tends to be 9 nodes and 8 edge. The third fact is that the network latency. So mostly the cluster are deployed in the same DC, I guess. But for some robustness deployment, they have deployed the cluster in different AZ or different regions. Then the network latency could be like a few milliseconds. That will also impact the transaction time. The last factor is about the log conflict points, because for example, in this topic, there if multiple nodes try to, multiple clients try to subscribe to the topic which have the same prefix, like AB, top AB, then there are some conflicts there. And the best idea is that once Malaysia transaction hits some log conflict, if it is newer transaction, it will just restart the transaction itself. So there will be lots of wasted execution. So you will see lots of CPU usage because of transaction restart. So now we talk about the solution. The first solution pop up in our mind is that since the cluster performance is not good as single node, so we try to bring it back to single node performance. That's why we introduced the table lock. Considering the subscription traffic normally it's not heavy, once client is connected and subscribed, then it will not subscribe again. So we think, yeah, it's probably okay to use table lock. Yeah, and the main benefit, yeah, sorry, I should go through it one by one. So the table lock tries to solve the issue that if we have lots of concurrent transaction running and those log conflict points per transaction to restart, and it could start over and over again. This is no good. So the table lock means that instead of using those fine granularity logs, we use whole table lock. That is, one transaction will lock the whole table. The other transaction will have no chance to lock anything, and we can ensure that one transaction can success once a time. Yeah. That's the benefit of using this table lock, but the bad side is that it cannot scale with a number of EMQX nodes in the cluster. Yeah, so this is our first approach. Okay, the second approach is using global lock. Because when we use table lock, we find that even we have less transaction restarts, but we can see that Malaysia local on single node is stressed. That's why we come with idea about using global lock. And the benefit of using global lock is that it makes transaction runs in 30 context. That means it has no need to communicate with Malaysia locker locally or remotely, so that it can just do transactions in 30 context and then sync the output, the writes to the other node. Yeah, that also becomes the bad side, because syncing the write to each node, it also takes time. And in current Malaysia implementation, each writes are synced to each node. This is not ideal, because what we prefer is that we can sync one transaction at a time. What I mean is a group, a number of writes, and then sync to the nodes. But currently, Malaysia is not doing that in sync 30 context. That's why we also trying to find a better solution, which comes to the next one, compact tree. As Dunning already present, that the idea of compact tree is that we, instead of having lots of nodes and the edge to write, we compact the nodes to a smaller writes and smaller zero edge. That makes the transaction very small. And also it makes the lock conflict unlikely to happen. If you have this kind of setup, you have the client ID, then have the wildcard token. And the best benefit of this is that it scales with the number of nodes in the cluster, because it has almost no lock conflict. The downside is that yeah, it's nightmare for hot upgrading, and it requires state type change, table schema change, and also the matching is a bit slower. I mean, already explained why it is slower, but in my mind, it's slower in microseconds level. Shouldn't be milliseconds, because it just requires a few additional X lookup. It should be in microseconds level, 100 microseconds for 5 level topic, I guess. Yeah. Okay, then by testing our solutions, we also found that the Malaysia transaction runs very slow when the broker process having a very huge queue. That is because that the Malaysia is not optimized to do receive marks or selected receive optimization. So in that case, we decided to having a separate worker process. That the worker process will have a very clean message queue. There's no any garbage in the not garbage, useless message in the queue to proceed with the transaction, like receiving the locked result or something. And this is no downside, so we just put it as default behavior. Yeah, also when the broker are receiving the results from worker process, we also improve the receiving side to utilize the compiler receive mark optimization, same as Malaysia. So both spawn and the receiving side are very fast now. This can solve the issue of message conjunction in the broker process. From my test, it's like at least 10 times faster then without receive lock optimization. Yeah, and we have a future solution, which is RLog. Dimitri will present to you in the next demo. That is that in terms of number of nodes, if you want to scale your nodes to like 16, 32 or something, it is better to use RLog approach, because RLog approach will have only 3 core nodes, or suggested as 3 core nodes. So the transaction synchronization and the locking will be only handled in these 3 nodes, and the rest of nodes will just get replicated the data in a eventual consistency fashion. So this is not done. We are expecting Dimitri's work to have to be Go production or something. Okay, so results. So I tested with. Sorry, I should fix this. I tested with version 4.3 official release with default configs. In AWS, and having 3 and 5 2x large instance, which is 8 cores, 16 gig memory per node, and with 4 logens, and I can easily reach to 2,000 subscribes per second. Compared to RTV4, it cannot handle 20 subscribes per second. Worth to mention that before 4.3, I managed to reach 4,000, but I don't know, for some reason today when I tested it, I can only reach 2,000. Maybe some issue in the environment. I will check it later. But anyways, the best benefit is that it scales with number of nodes. So our customer they can just add nodes and yeah, to increase the capacity or something. Okay, summarize about what to use about this configuration, route log type. Since we only backport some of the pics to 4.2.12, so it's ideally for single node and small cluster using the default key lock which is the same as before, is okay. But if you have very long network latency between nodes, I would suggest to use table lock. But if you have issue with spawning or using large instance, but you have very good network latency, you can use global lock. Okay, for 4.3, I think the default configuration key lock here can cover most of the scenarios. But only if you have very long network latency, I would suggest to use table lock. But usually, how long is the network latency? I guess it must be like about 2 milliseconds something. Yeah, and the same to the global lock. If only topic compression cannot help, you have weird topic setup, like you have wildcard topic in the middle of those, and then you create lots of so to say lock points, lock conflict points. Then I think global lock probably can help. And the global lock requires very low network latency because the synchronization need to be very fast. Yeah, any questions? Or I can start demo. Okay, so yeah, we can have questions after the demo. So in this demo, I have the same setup as I mentioned in the slide. 2x large instance in AWS, and they are behind one load balancer. I'm using AWS network load balancer with raw TCP. And I have, I already stopped, sorry, very nice. I have 4 load gens. I started. Then I will explain to you what are they. Oh, sorry, I started in different rate, but it shouldn't be that matter. Yeah. And I have one EMQ X console open to monitor the message congestion in the broker process. We are using observer. Yeah, so far there's no congestion. I think I started with this. With this command, that is, I'm using load gen in QTD bench, and it subscribes to this topic, and the topic has this root prefix, and this means it will use its client ID. Then there's 2 wildcard topic, and there's ABC in the middle, just to break these 2 wildcard token, and everyone will do 200,000 subscribes, and I use different prefix in 4 load gens to avoid client ID, so to say, to avoid they hit the same client ID, and then it becomes like a kicking scenario. And in each load gen, I have configured 200 IP addresses so that we have enough ports to use. Yeah. Let's see the GUI. So what I usually to monitor is this metrics, because I can see that the subscribe received and the sub-ACK sent, they look similar. That means we are able to catch up handling of subscribe. If the node is slow or the subscription is very slow, you will see that this number cannot catch this number. The sub-ACK is ACK for subscribe. CPU usage is low, I think. Each one has 8 core, and I think, yeah, so it's around, I would say it's around 50% of CPU usage evenly. That's nice. Is there anything you want to check? Yeah, you see that I have this prefix from different, some of them I forgot to apply prefix. Yeah, the prefixes from different load gens.
Thank you, William.
Yeah.
Any questions for William?
I haven't finished.
Okay.
Yeah.
We're behind the
okay.
schedule.
Oh, sorry. So I will stop the traffic, and then we will see the message queue in the broker process, and we can see how fast it can handle. Let me see.
So this is when unsubscribing happens, right?
Yeah, the client going offline.
So you can see the message queues are being queued by the EMQX broker processes.
Yeah.
And it's going down quickly.
Yeah. Yeah. Okay. At the same time, we can answer some questions if there are any. Okay.
No.
Thank you. Then I hand over to Dimitri.